Hello and welcome to this lesson on the electronic structure of metals and nonmetals. In today's lesson, we will explore how the atomic structure of metals relates to their positions in the periodic table and examine how their electron configurations impact chemical reactivity. Then, we will explore how the atomic structure of nonmetals relates to their positions in the periodic table and examine how their electron configurations impact chemical reactivity. To understand how the atomic structure of metals and nonmetals relates to their positions in the periodic table, we need to focus on electron configurations and chemical reactivity. First, let's consider metals. Metals are located on the left side and in the central part of the periodic table. If we look at their electron configurations, we notice that metals typically have a small number of valence electrons, usually between 1 and 3, in their outermost energy level. For example, sodium, Na, has 1 valence electron in its outermost shell. The further away the metal's valence electrons are from the nucleus, the less stable their position, and therefore the more reactive. This means these electrons can be easily lost during chemical reactions, leading to the formation of positive ions, known as cations. When sodium loses its 1 valence electron, it forms a Na+ ion. Generally, the fewer the valence electrons, the more easily the metal can lose them. The tendency to lose electrons makes metals good conductors of electricity and heat. This is why metals like copper and aluminium are commonly used for electrical wiring and cookware. We will look at how this works in much more detail in the bonding unit later in this course. Now let's switch to nonmetals. Nonmetals are found on the right side of the periodic table. Unlike metals, nonmetals have a larger number of valence electrons, usually between 4 and 8. For example, chlorine, Cl, has 7 valence electrons. Electrons which are closer to the nucleus are much more stable compared to those that are further away, making them less likely to be lost in chemical reactions. Nonmetals are more likely to gain or share electrons during chemical reactions, leading to the formation of negative ions called anions, or they may participate in forming covalent bonds, a concept we will explore later. For example, chlorine will gain 1 electron to complete its outer shell and become a Cl- ion. This tendency to gain electrons makes nonmetals poor conductors of electricity since they do not have free electrons to carry a charge. In summary, the atomic structure, particularly the number and arrangement of valence electrons, influences whether an element is a metal or a nonmetal and affects its chemical reactivity. Metals tend to lose electrons and form cations, while nonmetals tend to gain electrons and form anions or share electrons in covalent bonds. By understanding the layout of the periodic table and the electron configurations of different elements, we get a clearer picture of why substances behave the way they do chemically. In today's lesson, we delved into how the atomic structure of metals and nonmetals influences their positions in the periodic table, focusing on electron configuration and chemical reactivity. We began by revisiting the periodic table's layout, noting that metals are typically found on the left side. We discussed that metals generally have fewer electrons in their outer shells and are inclined to lose these electrons to achieve a stable electron arrangement, making them good conductors of electricity and heat. In the periodic table, nonmetals are found on the right. This arrangement is important since it reflects their distinct electron configurations. Nonmetals usually have more electrons in their outer shells and tend to gain or share electrons to attain stability, leading to lower conductivity. By connecting these principles, we understood why elements are positioned where they are in the periodic table and how their atomic structures dictate their chemical behaviors.